All right, so we're going to be talking about solving quadratic equations using the quadratic formula. So you can see here we have the quadratic formula along with what we consider to be standard form for a quadratic equation. Again, this part right down here, that is the formula that we'll be using, and this up here is, again, standard form. So anytime you go to use the quadratic formula, you do need to make sure that the equation you're trying to solve is in standard form. So you have your x squared term, your x term, your constant, and it equals 0. That part over there, that equals 0, is usually a pretty big indicator, right? If you don't have it equal to 0, you're probably not in standard form, and you have to do a little work first. So we're going to go ahead and use that. We're going to do this here as our first example. So you'll notice it's x squared, x, constant term equals 0. We do have this in standard form. So now we need to identify these numbers, these coefficients a, b, and c. So here for this first one, we have a 1 in front of x squared, so a is 1. And then for b, for the x coefficient here, we have a 10, so b is 10. And then finally for c, the constant here, we have 16. In this situation, all of these values are positive, though if we have subtraction here or a negative symbol, right, we would need to consider these as negative numbers. All right, so the next step is we need to plug these into our quadratic formula. Here's kind of the basic structure that I'll be using. Again, everywhere there was kind of a variable or one of our letters here in the quadratic formula, right? What I did was replace them with kind of some open parentheses so they can accept the different numbers that we have. All right, so this first value here is going to be a b. This one's also a b. Again, I'm looking at my formula over here. And then it's a on the top there and a on the bottom here. And then this one, last value here is going to be our c. So plugging in those numbers, these b's become 10. This a value is a 1, and this a value here is a 1. And then lastly, this part here, c is 16. Okay, so the next step is we need to kind of simplify this down and find our solutions. I like to think about the quadratic formula as sort of having 3 major parts to it. We have this part here, very simple. We just have to figure out how to apply this negative to the 10. Then we have this giant square root. This is sort of the more complicated part, and it's going to kind of determine what sort of solutions we'll have for our quadratic equations. And then lastly, the denominator here where we're doing 2 times a. So we'll go ahead and kind of solve these various parts. So this part here, we have negative 10, right? We just get negative 10. The plus or minus symbol, that's going to kind of always be included with our quadratic formula. This is how we come up with 2 solutions. And now we have our big square root. And so that part is going to be various ways to solve it, but I'm going to be using the calculator. You should use the blue calculator to kind of simplify this down. So I'm going to go ahead and pull up a calculator. So let me go ahead and pull this up. And yeah. So again, I'm going to be typing in exactly what I had on the inside of that. So it's 10 squared. Oops. Squared. Minus 4 times 1 times 16. Now, I do recommend when you do type them in, whether you're using your blue calculators or something else, use parentheses. That's going to make a big difference with this, especially when we're dealing with negative values. The calculator, the way they handle negative values, can cause us to get sort of the wrong answer, even though it looks like we've typed it in correctly. Anyway, the inside of that square root is 36, and that's actually a really nice value because the square root of 36 is a nice whole number, right? So if you type square root of 36 in the calculator, we should get 6. All right, let's go ahead and put that away and go back. So this big square root over here, simplified down to the square root of 36, which we came up with as being 6, so that's 6. And then lastly, our denominator, this is also usually a fairly simple one to do. We're just doing 2 times a number, 2 times 1, we get 2. All right, so this is one type of solution that we get when we simplify our quadratic formula, and that's what happens when the square root simplifies to a nice whole number value. We had a perfect square there on the inside, and we get a nice whole number value. So we're going to get either whole number solutions or possibly fraction solutions to this. And that's one type that we can get. So again, the way we're going to get two solutions is we're going to be splitting this up into two separate equations based on this plus and minus symbol. In one of them, we will do plus, and in the other one, we will do minus. So we get negative 10 plus 6 divided by 2. And then the other one, we get negative 10 minus 6 divided by 2. And again, we can kind of simplify these down. Negative 10 plus 6 is negative 4 divided by 2. Negative 10 minus 6 is negative 16 divided by 2. And obviously, both of those do simplify down. So this first one, we get x is equal to negative 2. And then for this next one, negative 16 divided by 2, we get x is equal to negative 8. Now, one of the things that this tells me, other than the fact that these are our solutions, is that this problem was probably factorable. We could have done this in other ways. Anytime we really get whole number answers like this, or even kind of decent looking fractions, it was probably a very factorable problem. We could have done this in a different way, but it's fine. Quadratic formula is totally valid. Alrighty, let's go ahead and move on to a couple more examples just so we can see some other things that can happen. All right. So here, one of the major things that you can see is it's not in standard form, right? It doesn't say equals 0. So we need to get rid of this 8x. We need to get rid of that, cancel it out. So it's positive, so we're going to be taking it away. And I have to take it away here on this side. Now, again, something you will notice here is that we don't have any like terms to subtract that from. So I'm just going to be sort of sticking it in the middle. That's where that x term usually goes in the quadratic formula anyway. So we get 2x squared minus 8x plus 3 equals 0, right? Because this cancels out and we get 0. Now we're in standard form. So we have our a value here, which is 2. We have our b value here, which is negative 8. And finally, c, the constant term there, is 3. Again, a always goes with x squared, b always goes with x, and c is always our constant term in case they're maybe in the wrong order. Alrighty, so plugging this in, a values go here and here. These are both our a values, which are 2. Our b values go here, negative 8, and here, negative 8. Again, this is a negative number because of the subtraction symbol that was in front of it. And then lastly, our c value goes over here. Alrighty. Again, I like to think about this quadratic formula as sort of having 3 parts to it. Here, and we're going to go ahead and simplify those down. So this one is tricky. We have this double negative situation going on, but a negative number or the opposite of a negative number, we get positive 8 for that. Again, generally, there's either going to be one negative symbol or two negative symbols in here, and you know, those 2 different ways we simplify it, right? If there's only one negative symbol, then this is a negative number. But if there's 2 negative symbols, they cancel each other out, right, and they become positive. So we get 8 there. Plus or minus, and then the denominator, 2 times 2 is 4. So next we have to simplify this big square root thing. And again, I'm going to go ahead and use the calculator. Again, type it in just like you see it here, but I'll go ahead and do that here on the side. So I get So I got 40 for the inside of that square root. So it is the square root of 40. Again, I like to calculate the inside first because it's possible we get a negative number in there. And then when if we try to do them at the same time and we're taking the square root of a negative number, we know that our calculator is going to kind of have a problem with that. It's going to tell us that there's not a real answer to that. So doing it in 2 parts sort of saves us from that issue. Anyway, hopefully you can simplify square roots on your calculator there, right? You plug in that negative square root of 40 here. And because that's 4 times 10, you get 2 square root 10. And so that's what I get right here, 2 square root 10. And again, the nature of this answer that we get kind of tells us what our solutions are going to look like. Because we got a simplified radical, not a whole number, not an imaginary number, anything like that, our answer is going to include this simplified radical, and we're going to try to keep it in exact form. Now, This one is not as nice as some of the other ones that we can do. A couple things that you can do to try to simplify this down is you can test to see if this number divides in here. 8 is divisible by 4, but 2 isn't, right? So that doesn't work. I can't do it that way. The other thing we can do is we can check to see if you can divide the numerator and the denominator by the same number, right? That's just a general way that you can simplify fractions. And so in this case, I notice 8 and 2 are both divisible by 2, and so is 4. So everything here is divisible by 2. Don't mess with the square root. I'm not dividing that. I'm just dividing that number in front. So I'm dividing the top by 2 and dividing the bottom by 2. So that's going to give us 4 plus or minus 1 square root 10. Now this 1 could be left off, right, because we're multiplying it by the square root of 10, and multiplication by 1 doesn't really do anything, but I'll leave it here for now. And then 4 divided by 2 is 2. So this is as simplified as we can sort of get for our solutions. Now we could split them up into the two different answers, right, based on our plus or minus symbol, but I'm going to go ahead and just leave it like this. This is sort of an exact radical solution. And again, that's very different than those whole numbers we came up on the last one. So this is kind of another thing that we can do, having this exact radical solution. Or rather, solutions, right? This does represent two different answers because of the plus or minus symbol. Alrighty, we're going to go ahead and do one more just to sort of see a different type of answer that we can get. And we'll go through this one a little bit quicker until we get to that kind of nuanced difference. So we are in standard form, equals 0, x squared minus 6x plus 34, right? It's in standard form. Our a here is 1, b is negative 6, and c is 34. So we're going to be plugging these numbers in. A goes here and here. B is negative 6 in those two locations. And then finally, C is 34. All right, I'm going to, again, go a little bit quicker, simplify this, and then we'll deal with this big square root. This is where things are going to be a little bit different for this problem. So double negative, we get positive 6 plus or minus. 2 times 1 is just 2, and then we'll figure out that big square root. So I am going to calculate there what is on the inside of that. So negative 6 squared minus 4 times 1 times 34. And so I get negative 100. So I have the square root of negative 100. And if I try to use my calculator to say, what is that? It's going to say non-real error, because this is not a real number. We are trying to take the square root of a negative. We have to remember that is going to give us an imaginary number. So this is going to be the square root of 100 with an I on it, right? An imaginary number. So if you simplify that square root, you actually get 10. So our answer here for this one is going to be 10I. So this, again, is another type of solution we can get. We're going to get a solution that involves an imaginary number. Our solutions are actually going to be complex numbers. All right, let's see what we can do to simplify this. This time, dividing through with this number does work. These are both divisible by 2, so we can go ahead and simplify this down. 6 divided by 2 is 3. 10I divided by 2 is 5I. So that is our simplified complex solution. This is a complex number solution. Or again, rather solutions, because this does represent two different answers, right? 3 plus 5I and 3 minus 5I. And the quadratic formula is one of the only ways that we can find solutions like this that are complex numbers. All right, go ahead and stop there.